Welcome to qnawire.
Hi, so for this question, we have the following reaction that is occurring at 1000 Kelvin, which is the reaction of carbon as a solid plus water as a gas that is going to generate, upon heating, CO as a gas plus hydrogen gas. The value for Kc for this reaction at this temperature is going to be equal to 3 times 10 to the minus 2, and we want to calculate the equilibrium concentrations of water, CO, and H2 in a reaction mixture, which is obtained by heating initially the following quantities. We had 6 mole of steam, 6 moles, and in the case of carbon as a solid, we have 45 grams of carbon. Remember that carbon has a molar mass of 12 grams per mole, so this is equal to 3.75 mole of carbon. Okay, so initially we have 0 and 0 of each of them. Now what we are going to do is proceed employing the equilibrium constant to know what is going to be the equilibrium concentrations. So out of this reaction, a portion is going to react, which is going to be an X value over here. This is going to generate plus X and plus X on both sides of the equation. And we're told that at equilibrium, then we should have 3.75 minus X, 6 minus X, X, and X. We know that the equilibrium constant is quite small, it's 3 times 10 to the minus 2. So maybe we can make some approximations along the way. So first of all, let's write the value for Kc. Remember that for equilibrium constants, we don't consider any condensed phases because they are not going to enter into the equilibrium equation. So in this case, the value for Kc is going to be equal to the concentration of hydrogen times the concentration of CO divided by the concentration of water that we have on our vessel. So now we can proceed, but we need to be careful with the ice table that we made because we started with molarities. So what we're going to do is transform this into concentrations since we know that the volume of our recipient was equal to 5 liters. So the concentration of water is going to be 6/5, which is equal to 1.2 molar. We can replace the value here, and the X that we're going to use is going to be the same. As you can see, we don't really need the value for the concentration for the carbon because we're not going to use it in the equilibrium equation. So I'm just going to put it as reference to know when we are going to have a condition while solving the equations, because if we have a value that exceeds the amount of carbon, then we know that that is not going to be possible and that all of the carbon is going to be consumed. So for this, the concentration of carbon would be 0.75 molar. So 0.75 minus X. Now we can proceed with directly substituting the values that we have. We have X and X over here, and we are going to get 1.2 minus X. This needs to be equal to the value for the equilibrium constant, that is 3 times 10 to the minus 2. So we have two options, solving the quadratic equation or solving while doing an approximation. So a way to check is that if we make the approximation that 1.2 minus X is approximately 1.2, the result that we would get for solving for X would be equal to 0.19. And this would be 0.19 molar. If we do this approximation, you're going to realize that the value of 0.19 represents approximately as 16% of 1.2. So we cannot do this approximation because the value exceeds the 10% threshold that is employed generally for that. So we need to solve the full quadratic expression. which is equal to x squared is going to be equal to 3 times 10 to the minus 2 multiplied by 1.2 minus x. After we have solved this quadratic expression, we get two different values for x, x1 and x2. And x1 is going to be equal to minus 0.205, and x2 would be equal to 0.175. So, as you can see, the correct result would be 0.175 molar. So, we have found the value for x. We know that concentration of CO gas would be equal to x equal to 0.175 molar. This is the same as the concentration of H2 gas. After that, the concentration of water in molarity would be equal to, according to our ice table, 1.2 minus x, as you can see here. 1.2 minus x, which is equal to 1.025 molar. And this would be the composition of the gas. Now, to know the amount that would be left of carbon in our sample, we simply need to calculate the value here. We know that for carbon, in 5 liters, we initially have the value of 0.75 minus x, which is in molarity. So 0.75 minus 0.175. This is mole per liter. And we are going to convert this employing the molar mass, which is 12 grams per mole. As you can see, the units are going to cancel out, and the result is will be equal to 34.5 grams of carbon left in the container. So that would be all. Thank you very much and have a good one.